Welcome back to OneOps User Training Level 1, Beginner. We are going to get started today with actually defining what components and platforms or parts our cloud application is composed of. This is called design in OneOps. The representation of a cloud application in OneOps is called an assembly. It contains the design of our application, but also later is the container for working with it in getting it ready for deployment and then running in an operation. Creating your new cloud application container, the new assembly, is as simple as getting to the assemblies list in your organization and pressing the new button or the new assembly link. In this new assembly screen, we simply provide a name for our cloud application. In this case, we're calling it Pete's Pet Store, because we're going to create a simple pet store application. We can give it a description, and we have to provide the owner's email address, or typically also a mailing list, so that multiple people can be sort of the owners and be notified. Once we've added the email address, we simply press save, and our new application is ready to be used. Essentially, this new assembly is just a container for our application design, and really we can't do anything with it. Yet what we have to do is we have to add platforms. So what is a platform? A platform designs the parts of your assembly, which then in turn is composed of components. And example platforms are Apache Tomcat, Apache HTTP Server, Node.js, and many others. In order to add a platform, all we have to do is press Add Platform, and then we have to give it a name. In this case, we are calling this the web app server. And we are going to use the pack source OneOps, which is the open source pack source. And from within it, we are going to select the Apache Tomcat web application server. This already shows us some information, but essentially about the usage. But essentially, we are happy to roll with this configuration, and we can just save this platform. What this now has done is it has created a new platform based off this pack, and this platform is based on multiple components, and they are pre-configured, and you can see our setup here. There's the Tomcat application server, which needs Java, both of which need the operating system, which needs to be installed on compute. We also need a load balancer and a fully qualified domain name. And so this is the overall setup created from this platform that we selected with the simple configuration of calling it web app server and choosing the template. In the configuration for the platform, we were required to set a pack source in order to use a pack to create a platform. The pack is nothing else than the template that created this collection of components. They come from what's called circuits and also show up in catalogs. And the open source circuit with all the definition for those is actually just located in GitHub and available there. It is basically a collection of chef recipes that allows you and OneOps to configure these platforms. Looking at the design created by choosing the Tomcat pack and getting the Tomcat platform created, we see that there's a number of components that were added, namely compute, OS or operating system, Java, and Tomcat. So let's explore these components a bit further and maybe tweak their configuration a bit here and there. Keeping track of changes in OneOps works similar to version control systems such as Git or Subversion, where a number of changes you can make can be committed, and then later you can look at the differences, and you can also look at the changes in a review before you commit them. So we are going to just commit this initial setup as it is, and then later we can check the differences for the changes we have performed. In the design of our Pete's Pet Store, we can now move over to the web app server platform and have a look at the different components on the right here. So let's first start with the compute component. The compute component is pre-configured to use a standard instance size. We could edit that and change to all sorts of other sizes. But as you know, cloud applications should by default use small nodes and scale horizontally. So we're going to leave this and be happy with that. And apart from that, we don't need to perform any further configuration. So we can basically just leave it as is, so we can't cancel our editing. Navigating back to the platform by clicking on the link up here allows us to see again the list of components, and we're going to check out the Java component next. The Java component here is pre-configured automatically to use OpenJDK, JDK 8. If we wanted to modify that, we could go and change this to Oracle Java and use the same JDK. Everything else we are happy with. If I now save this, you will notice that now the review and commit design feature came back up. And if we have a look at the review, we can see that there's a change here that changes OpenJDK to Oracle. And we could proceed with this change. And now with this change performed, we can look at the timeline, and we now see that there is two different changes. The second one being our Java upgrade, the earlier one being our initial creation. Next, we're going to modify the OS or operating system component. And we change this to a newer version of CentOS that we want to use in this particular testing environment later on. We also not gonna worry about the Windows domain services, so it is marked as optional, so we can actually disable it. And with that, we can also see that there's much more configuration on the operating system possible, but in our case, we are happy with this little update, and we can again review the design changes and commit them. The last component configuration that we want to change is the Tomcat application service configuration itself. What we're going to do for that configuration is we're going to get rid of the binary distribution mirrors because they are automatically configured in our cloud environment already to download them from internal repository servers, and we're going to upgrade the version to the latest version of Tomcat 7. We also see that there's a whole bunch of further configuration possible of various aspects of Tomcat, but we don't need to dive into those details to get our application running, so we are happy with that. And with that, we have our Tomcat application server ready configured to run our application. Now that our design is mostly done, let's have a look at various aspects such as summary, variables, timeline, diagram, and platforms, most of which we've already seen, but just recapturing for a second here. In the summary view of our Pete's Pet Store in the design, we can see that the release status is displayed as well as the list of platforms. At this stage, we only have one platform because we are dealing with a very simple application. It is, however, possible to add multiple platforms and then also declare the dependency amongst the different platforms, which would then show up also here in the diagram and detail that more. You can define variables, and we can also see the timeline of the various changes we've already performed. In addition, these buttons at the top here allow you to extract your current configuration into a YAML or JSON file and then load it in another place or copy it to another application. In order for our assembly to reflect anything beyond a simple application server running, we need to do some further configuration, and that is done by adding what's called optional components. In this case, we're going to add the artifact component to specify the WAR or Java Web Archive, Web Application Archive, that will be loaded in our application. Jumping back into the web app server configuration and looking at the components on the right here for this web app server, we see the artifact component here and no entity configured. So what we're going to do is we add a new one. Configuring this artifact component, we give it a name like Pet Store WAR. For our example, we are basically going to use this JPEG store from the MyBetis project, and we're going to use this specific war. In order to do that, we are configuring the repository URL by using a cloud-specific variable and the repository name from which the artifact will be loaded. In addition, we now have to configure the artifact itself. In terms of the artifact component, we simply provided the group ID, artifact ID, and packaging here as the values in the identifier in the Maven convention following the colon-separated values, and then the version 602. We also configured an install directory of app.jpg store and set it up so that the app user will do the expansion and work as that user. Last but not least, we want to configure what should happen in the restart of the application or when the artifact is installed, which we are going to use to hook in the extracted war that we've got to be expanded here into the Tomcat server's web apps folder. The command we're inserting here for the restart stage is a Ruby command. So in this case called execute, which just means that an operating system specific command is going to be called. We're calling the ln-s command, which will create a symbolic link, and it will be from app.jpg store, which is the directory where the war is exploded. It is exploded as a current directory, and we are symlinking this folder to the pet store folder in opt Tomcat 7 web apps, which basically is where the web applications exploded are stored and from which where Tomcat picks them up to run. With this configuration, we should be able to automatically have the pet store application running when Tomcat starts. So finally, we can do one last review and commit and then move on. We saw here in our review that we added the pet store war and other things got added, and we could confirm all the details in here, but we're confident that we did the right thing. So we're just gonna say added pet store war. We're committing this, and now we are ready. So our design is now ready to be used. So recapping, what we were able to do is we defined our cloud application. We chose different packs as templates to form our platforms. Each platform, where we in this case only chose Tomcat as a platform, contains multiple components such as Tomcat, the application server, as well as Java, the operating system compute. All of this configuration is now done and ready to be used. And we have not specified anything about a specific cloud-related deployment or anything like that. So we are completely independent of what cloud this is going to be. And as we'll see in the next episode, we will see how we can use this to deploy our application or get it ready to deploy in multiple different environments in what's called the transition.